In this next video, we gonna continue a little bit more about the plane. Okay, so this one is gonna be about the distance between point and plane. So you have the point P1 outside your plane. So this one is your point P1, and the P1 has the coordinate x1, y1, and z1. And you like to know how far from this point to your plane, and that distance is called d. So in order to determine this distance, you see that you have one point on the plane called P0. So this point is on the plane, and this point will have the triple x0, y0, z0. Okay, and you have P1, which is x1, y1, and z1. So you're gonna like to find the distance from P1 to the plane. Okay, the plane here, it has equation. So that is going to be the plane M will have equation ax plus by plus cz equal to d. So for finding the distance, you see that you can find the vector P0, P1. Okay, so you have the vector P0, P1 that is kind of a long vector. And you like to find the distance here, and this distance here, you see that the thing that we know is going to be, we have one vector that perpendicular to the plane, which is the normal vector n. So you have your normal vector n here, okay, that is gonna be the vector that perpendicular to your plane, and you're gonna like to project. Okay, so I'm gonna make the vector P0P a little bit darker so you'll be able to see better. So it's gonna be, I would think this color should be okay. So if you like to draw P0, P1, okay, so you see the blue vector. So we're gonna project this vector. So you see that we can project this vector, and you see that the vector that you have here turn out to be just, if you consider a light here and you project this light, so you see that you would get the shadow. So you would get the shadow here. Okay, so this one will be the length of the projection vector. So you have this one is going to be the projection vector of P0, P1 onto, okay, it's going to be the projection vector of P0, P1 onto the vector n. Okay, and if you be able to compute the length of this projection, it's going to turn out to give you the distance that you're looking for. So that's going to be the step that we're going to proceed. So you see that we have point P0, x0, y0, z0, and you construct the vector B, which is P0, P1, and this will give you B equal to x1 minus x0, y1 minus y0, and z1 minus z0. And the distance from P1 to the plane will be equal to the absolute value of the scalar projection. So the scalar projection will be just absolute value of the norm of the projection vector. So we have the name for that. If you recall at the beginning of our lecture, we have the thing that called the component. So we have the component of the vector B onto n. So this one is going to be absolute value of the component of B onto n. So that given by the formula n dot B over norm n. This one is kind of far, okay? So if you like to recall this guy, it's going to be when we study the dot product. Okay, so it's going to be here. It's going to be on this page that we have the component is on page 20. Okay, so this one is going to be like the length of the distance that we are looking for. Okay, so let's go back to our calculation. So you see that this one will be just the plug in the formula n dot b. Okay, so what is n and what is b? Our n turned out to be just A, B, C, and our B will be just x minus x0, y minus y0, and z minus z0. Okay, and you're gonna just, oh, I forgot one. So it's gonna be x1 minus x0, y1 minus y0, and z1 minus z0. And so you're gonna dot A with x1 minus x0, and B is y1 minus y0, and C is z1 minus z0. So that is going to be the result of that dot on top, and you have norm n. Norm n is going to be square root a square plus b square plus c square as usual. Okay, so this guy is going to be just square root a square, b square, and c square. Okay, so in this case, you see that you can simplify this one a little bit by gathering x1, y1, and z1 together into one term. So you're gonna gathering them, okay? That is gonna be for x1, y1, and z1 multiply with a, b, and c. And you're gonna gathering the term with x0, y0, and z0. So it's gonna be ax0, by0, and cz0. So that is gonna be for x0, y0, and z0. However, the point P0 turned out to be on the plane. So it's on the plane, so it must satisfy the equation of the plane. So it's going to be ax0 plus by0 plus cz0 equal to d. So you're gonna just have this guy equal to d. Okay, so this guy must be equal to d. So the blue guy is gonna be D, okay? And you have the yellow guy, just copy it out. So this will give you the formula for the distance from the point P1, x1, y1, z1 outside the plane to the plane ax plus by plus cz equal to D. Okay, so that will be just the thing that you have. Okay, so let's try to do one example. We like to find the distance from the point P1. Okay, so you get x1, y1, z1. Okay, so you have x1, y1, and z1, and you're gonna have the plane. Okay, so this one will be your plane. So the distance D turned out to be just absolute. So you're gonna see that it's gonna be just, you're gonna plug in 3, 0, and -2 into the plane. Okay, so it's gonna be 3, okay, and 0 minus 3 times -2, okay, and it's gonna be, you're gonna have minus of -2, okay, so that is my D, okay, so that is my D, and it's gonna be over, square root of the normal vector. So it's gonna be square root for the norm of the normal vector. Let's find out n first. So you're gonna have n in this case by reading the coefficient of the x, y, and z respectively. So it's gonna be 1, 1, and -3. Okay, so this one will be just 1 square, and -3 square. So in this case, you're gonna just have I would say that I have absolute value of 3 plus 6 plus 2 square root. Okay, on the bottom, you would get square root 1 plus 1 plus 9. So it's gonna be 11 over root 11. Okay, and this one will be square root 11 for final answer. So this one will be just the square root of 11 for the distance from P1, 3, 0, negative 2 to the given plane. So let's conclude this one a little bit. So the question will give you one point outside the plane, and it's going to give you the equation of the plane, okay, and ask you to find the distance. Okay, so you may not need to know how to prove the formula, but you may recognize that the formula comes from the orthogonal projection. So it's going to come from the projection, and the thing that you need to memorize turn out to be just this formula. Okay, so let me box this one a little bit. So I would like to box this guy. Okay, so that is going to be the formula. The next one, you like to find the distance between the parallel plane. Okay, so you see that you have the plane, you have n1. Okay, so you have n1 equal to 10 to negative 2, and you have n2 equal to 5, 1, and negative 1. So you see that n1 turned out to be double of n2. So they are parallel. So n1 parallel with n2. Okay, so n1 parallel with n2. So these two planes are parallel. So you like to find the distance between them. So this one, let's draw two planes. Okay, so you have two planes that parallel to each other. So the idea turned out to be just if you like to find the plane, or if you like to find the distance between two parallel planes like this one, basically we're gonna just pick one point. Okay, so we're gonna just basically pick one point from the top plane, and we're gonna just find the distance from that point. Okay, so you're gonna just pick one point from the top plane, and you basically find the distance from that point to the lower plane. Okay, so that will give you the distance that you are looking for. So in this case, this one will be the distance d. So you have the distance d, okay, turn out to be just, you can pick any point, okay, so you can pick any point. So the way to obtain the point here is gonna be just, you may just plug in the term that makes the variable y, z disappear, okay, and you're gonna be able to solve for x. So the way to that I see is going to be, if you have y equal to 0, z equal to 0, what is x? So you have 10x equal to 5. So you would get x equal to 0 0.5. Okay, so you have x equal to 0 0.5. So you put y equal to z equal to 0. Okay, so you put y equal to z equal to 0 into the plane. So the point that you choose turn out to be 0 0.500. Okay, so it's going to be the point on the top plane. And you have the equation of the bottom plane, which is 5x plus y minus z equal to 1. So the distance d gonna be absolute value of 5 times 0 0.5 minus, not minus, so it's gonna be plus 0 minus 0. Okay, so this is your x1, y1, and Z1 respectively, and you're gonna have minus 1. Okay, so you minus 1 and you put absolute value on top, and it's gonna be square root, and minus 1 here come from d that you have here. Okay, so it's gonna be minus 1. And so on the bottom, you would just have 5 square plus 1 square plus negative 1 square. Okay, so that come from n2, the norm of n2. So in this case, you're gonna just calculate the number. So this one, let me make this one a little bit smaller. And I'm gonna put this one on the side. So you're gonna have 2.5, so it's gonna be 1.5. Okay, so it's gonna turn out to be 1.5, and on the bottom it's gonna turn out to be 25 plus 2, so it's gonna be 27. Okay, so it's gonna be 1.5. Okay, so it's gonna be 1.5 over 3 root 3. Okay, so it's going to be 1.5 equal to 3 root 3. So this one will give you 1 over 2 root 3. Okay, so you can get rid of 1.5 and 3. So this one will give you 2. Okay, so it's going to be 1 over 2 root 3. Okay, so that will be the distance that you're looking for. Okay. The next one, you like to find an equation of the plane consisting of all points that are equidistant from the point 1, 0, negative 2, and the point 3, 4, 0. So when you first read this question, you may think that it's going to turn out to be using the distance formula. However, it's not. The thing or the idea for doing this one is going to be, you're going to have one plane, okay, in the middle, and you're going to have 2 points in between. Okay, so you're going to have 2 points, and they are 1, 0, negative 2. And you have here, which is 3, 4, 0. Okay, so you see that your plane has the property that you have equidistant. Okay, so it means that if you draw or you connect these 2 points, you're gonna pass this plane. Okay, so you're gonna connect these 2 points, and this gonna connect. Okay, so it's gonna connect this plane, and let me erase this one. So you see that you're gonna have the connection between these 2 points, and you see that you have the point in the middle. Okay, so you're gonna have something in the middle like this, and this gonna give you equidistant. It means that you have the same distance. Okay, and if you have any other point in the plane, it's gonna behave in the same way. For example, if you just like this point, okay, on the plane, and if you consider this one, okay, so let me also draw another one, so you get this one like this. So you see that this guy turned out to be equidistant with this guy. So you're gonna get another triangle that is gonna turn out to be isosceles triangle. Okay, so that is gonna be the picture that you must keep in mind, that you're gonna have like the point, every point on the plane turn out to be like equidistant from these 2 points. So the way in order to obtain the plane turn out to be, what will we need when we like to find equation of the plane? So we like to find equation of the plane, right? So we like to find equation of the plane. So the thing that we need turn out to be, we need 1 point on the plane. Okay, so we need 1 point on the plane. one point on the plane. And another thing that we need turn out to be the normal vector. One vector perpendicular to the plane. Okay, so we need one point on the plane and we're gonna need one point that are not one vector that perpendicular to the plane. Do we have them both from this picture that you can see? So you see that if you need one point of the plane on the plane, so you can use the midpoint. Okay, so this green point turned out to be the midpoint. Okay, between these two guys. So the midpoint is gonna turn out to be the average between this component. So it's gonna be the midpoint turn out to be 1 plus 3 over 2. You basically find the average and you have 0 plus 4 over 2 and you have negative 2 plus 0 over 2. Okay, so that will give you the average. So, and the point that you have is gonna be 2, it's gonna be 2, and it's gonna be negative 1. So the point is 2, 2, and negative 1. And you need one vector. The vector that you can see is going to be, you like the one that perpendicular to the plane. So you see it right in front of your eye here that you have this orange vector. Okay, so this orange vector will be the vector that perpendicular to the plane. Okay, so that is going to be the orange vector. And this guy is perpendicular to the plane. Okay, so it's gonna be this guy perpendicular to the plane. Okay, so this vector perpendicular to the plane, and you're gonna have n given by what? It's gonna be just, you have this vector n given by, you have the terminal 4 minus 1, not 4 minus 1, 3 minus 1, 4 minus 0, and 0 minus minus 2. Okay, so it's gonna be 3 minus 1, 4 minus 0, and 0 minus minus 2. So it's gonna be 2, 4, 2. Okay, so you have the normal vector n given by 2, 0, 2, 4, 2. Okay, so it's gonna become 2, 4, 2. So you have two ingredients that you need in order to find the equation of the plane. So this will allow you to basically find the plane right now. So your plane will be, okay, so it's going to be just 2, 4, 2. Okay, so it's going to be 2, 4, 2 dot by the vector x minus 2, y minus 2, and z plus 1 equal to 0. And you may expand this one, so you would get 2x plus 4y, okay, plus 4y plus 2z equal to, okay, so let's calculate. So it's going to be minus 2 minus 8, so it's going to be minus 10 plus 2, so it's going to be minus 4, sorry, minus 4 minus x plus 2, so uh, it's gonna be 10, so it's gonna be 10 on the other side. Okay, so it's gonna be negative 10, so it's gonna be 10. So the equation that you are having is gonna be x plus 2y plus z equal to 5 for final answer. Okay, so this will give you the equation of the plane that the question asks you to find. Okay, so it's going to be x plus 2y plus z equal to 5. Okay. The last question, okay. We like to find parametric equation for the line through the point, okay. So we know that, hey, the question is generous enough to give you the point. Okay, so you know that it must be used in order to find the equation of the line. Okay, however, the other ingredient in order to find the line is gonna be, so we need direction vector. Okay, so we need a direction vector v. Okay, so we need a direction vector. So we read the question more. So it's gonna be the line that parallel to the plane. Okay, so it's gonna be parallel to the plane x plus y plus z equal to 2. So we're gonna analyze the question a little bit. So you have plane, okay, and your line here is parallel to this plane. Okay, so your line here is parallel to this plane. That have this line parallel to this plane like this one. Okay, let's make it a little bit slighter. It's gonna be like this, and then it's gonna be perpendicular to the line x equal to 1 plus t, y equal to 1 minus t, and z equal to 2t. So let's first notice that this guy, okay, so let's first notice that this line has the direction vector. Okay, so direction vector v is gonna be 1, negative 1, 2. Okay, so this one is gonna be 1, negative 1, 2, and the line here is gonna be this line. Okay, so this line is going to be this line. And you know that these two guys perpendicular to each other. Okay, so you have these two guys perpendicular to each other, and the line here has the direction vector v, okay, equal to, so you have v equal to 1, negative 1, 2. Okay, so it's going to be v, and it's going to be 1, negative 1, 2. And another thing is come from the plane. You have the plane has the normal vector. The normal vector for this plane turn out to be n. Okay, so you have the normal vector n equal to, let me use it here. So you have n equal to what? 1, 1, 1, right? So it's going to be 1, 1, 1. So you have the plane has normal vector 1, 1, 1. Okay, so n is 1, 1, 1. Okay, so that is going to be all of the information that we have. And you also see that the normal vector, and if you have this line, okay, if you have this line, the normal vector turn out to be perpendicular to this line as well. Okay, the normal vector turn out to be perpendicular to this line as well. Okay, so let me give you the thing that you can see. So you have the plane and you have the line parallel. Okay, so it means that you have the line that parallel this one, and my normal vector is here, you see. So my normal vector is the vector that perpendicular to my plane. Okay, so it's point out from the plane, and you see that in order to have my line perpendicular to the plane, it's gonna be, you're gonna have these two vectors must be perpendicular to each other. Okay, so you see that two vectors here perpendicular to each other. So you see that the line, okay, so this direction vector, okay, so we're gonna conclude that the direction vector of the line, okay, so okay, and this direction vector, let me just give in terms of need a direction vector, let's say A, okay, we need a direction vector, say A, so it's going to be say A. So we know that, A perpendicular to V and A perpendicular to N. Okay, so we know that from the information that give in the question, we know that it's going to be, you have A perpendicular to V and A perpendicular to N. So we may use, okay, so we may use A to be just the cross product between N and V. Okay, so we may just use the cross product between N and V. So in this case, it's going to be just I J K, and it's going to be, what is N? N is going to be 1, 1, 1, 1, 1, 1, and V is going to be the orange one, which is 1, negative 1, 2. Okay, so we have A equal to this one. So we know the direction vector. Okay, so we know the direction vector, and we have the point. Okay, so we have the point. So you're going to be able to find parametric equation of this line. So for this example, I will let you finish this one by yourself first, and then I give you the solution for the number that you can compute for A and the parametric equation of the line during the recitation. Okay. So that would be it for the plane. So in order to study the plane, it's going to be just basically two topics. You have to be able to find equation of the plane, and you have to like show some relationship between the plane and the line that you have. And in this video, we discuss about the formula for the distance from one point outside the plane to the plane. Okay, so I will talk more a little bit during the recitation on this one. Okay, so that's it for this lecture.